Hey everyone, and welcome to this explainer. I am absolutely thrilled to guide you through today's topic because we are going to explore something truly fascinating: how we can truly understand animals through structured, multidimensional observation. We're going on a bit of a journey today, bridging two incredible areas of science. First, we'll peel back the layers on the internal, emotional world of animals. We're going to look at how scientists actually measure something as complicated as empathy. Then we'll pivot and look at their external physical health, specifically the clinical precision it takes to read an animal's vital signs. By learning how to systematically observe both their minds and their bodies, we're going to uncover a much deeper understanding of the creatures we share this planet with.
Okay, let's dive into this, because this is exactly where our journey begins, with a question that really challenges our everyday assumptions. Think about rats. They aren't exactly the first animal we give the benefit of the doubt to when it comes to complex emotions, right? But back in 2011, a famous behavioral experiment published in the journal Science set up a brilliant dilemma. Picture this. You put a hungry rat in an enclosure. On one side, there's a cage mate trapped in a little tube. On the other side, a pile of delicious chocolate. So what does the free, hungry rat do? Well, the answer literally shook the scientific community.
Section 1. More than just instinct.
This whole setup was designed by behavioral researchers who wanted to systematically prove whether animal altruism is real or just some random reflex. And in that study, the hungry rat actually chose to prioritize its cage mate over its absolute favorite treat. It went right up to that small, narrow prison, figured out how to open the latch, and liberated the trapped rat first. Only after its friend was free did it head over to share the chocolate. And the researchers didn't just stop there. They systematically proved this wasn't just instinct. They found that rats only perform this rescue mission for friends they actually know, not for random strangers. This proved that the other rat's the stress was the real driver here. It was a targeted social response. So what does this all mean? It brings us to a massive, really profound question. Is empathy, that shared emotional connection that supposedly separates us from basic predators, a purely human superpower? Historically, empathy has been viewed as this uniquely human psychological glue. Sure, we easily project it onto our pet dogs, but what about other species? For centuries, the rule of thumb was basically, if animals don't feel exactly like we do, they don't feel empathy at all. We desperately needed a way to strip away our human hubris and scientifically measure this invisible trait without all that bias. Section 2. The Empathy Dimensions. And this brilliantly illustrates the massive breakthrough made by Dr. Albert Nguyen's team, who completely changed how we measure these traits. We're finally moving away from what's called binary empathy, that outdated, dogmatic yes or no assumption that a creature either has human-level empathy or none at all. Instead, Dr. Nguyen's team gave us the graded profile. This is a multi-dimensional scale that allows us to precisely map out exactly what kind of empathy different species possess on a gradual scale. It completely replaces philosophical guesswork with hard, measurable data. To make this rigorous, the team carved out 5 distinct dimensions that make up empathetic behavior. First, registering emotion. Basically, can you recognize another's basic emotional state? Second, registering situation. Do you understand their physical predicament? Third, registering mental states. Can you perceive hidden intentions or beliefs? Fourth, behavioral flexibility. The helping behavior has to be adaptable, not just some rigid, pre-programmed instinct. And finally, other-oriented. The action must actually be geared toward helping the other guy, not just doing it for personal gain. When you take those 5 dimensions and map rats against them, the results are wildly revealing. Rats actually score moderately high in behavioral flexibility and in registering the emotion and situation of their trapped buddy. They score moderate in being other-oriented, but their registration of complex mental states, that's almost non-existent. Basically, a rat doesn't know if its friend is feeling embarrassed or if it's carefully plotting an escape, but it absolutely knows its friend is distressed. So rat altruism is definitively a form of empathy on this graded scale. It's just a different profile than ours.
Section 3. Beyond basic vitals.
Now that we've seen how meticulously researchers can map out an animal's internal emotional world, we're going to shift gears. Let's see how this exact same systematic rigor is applied to assessing their external, physical health. Just like analyzing empathy requires a tight framework, assessing a sick animal requires a highly structured clinical approach. In a really insightful veterinary presentation by Chantel Alexander regarding advanced vitals, she highlights that whether a patient is crashing or completely stable, your process has to remain identical. Consistent data collection is the absolute foundation for catching when something goes wrong.
Think about it. You literally cannot spot a deterioration if you haven't systematically gathered the baseline data first. To get us all on the same page and empower you with the exact vocabulary vet nurses use every day, let's decode some essential clinical abbreviations. RR and RE stand for respiratory rate and effort. HR and PR are heart rate and pulse rate. MM means mucous membrane color, and CRT is capillary refill time. Both of those are absolutely crucial for checking circulation. Finally, SpO2 stands for the saturation of peripheral oxygen. These are the core metrics of life. Let's move to Section 4, the distance examination, and see how this builds. This is where the true science of clinical observation really kicks in, because you can gather a massive amount of rich data before you even lay a finger on the animal. There's a fundamental rule here: a distance exam should be performed at a distance. By just stepping back and looking closer, you get totally unbiased information. Are they resting comfortably? Is their posture normal? Or are they orthopneic, meaning they literally can't lay down because they can't breathe? Are you hearing snoring or harsh breathing noises? Assessing their resting state before the stress of being handled kicks in is an incredibly vital first step. While you're looking from afar, one of the most critical things you're assessing is their level of consciousness, or LOC. This operates on a sliding scale. At the top, you have BAR, bright, alert, and responsive. Then it moves down through depressed, obtunded, stuporous, and tragically down to comatose, where there's zero reaction to any stimuli. Tracking these changes over time is a game changer. A dropping LOC can be a massive red flag for hidden, severe issues like underlying pain, swelling in the brain from trauma, poor blood flow, or even dangerous electrolyte imbalances.
If an animal's level of consciousness starts deteriorating, make no mistake, it is an absolute emergency. The veterinary team has to act fast and systematically. They'll immediately check all perfusion parameters, like heart rate and blood pressure. They'll assess the pain scale, meticulously double-check medication doses, run baseline bloods for things like glucose, and often perform quick ultrasound scans, called a FAST or T-FAST, to look for internal bleeding or trauma. It's a rapid, highly structured cascade of observation and action.
Section 5, Oxygen and Respiratory Signs. Let's transition into a highly technical but super important area: the precise mechanics of how an animal breathes. We have to pinpoint exactly what kind of respiratory effort we're dealing with. For cats and dogs, normal is usually under 40 breaths a minute. Anything above that is tachypnea. Dyspnea means they are actively struggling to breathe. And the specific noises they make, they're like acoustic clues. Stertor is a low-pitched snoring sound, think of a pug breathing, while stridor is a harsh, loud noise pointing to large airway disease. Fun fact, if the struggle is on the inhale, the problem is usually up high in the upper airway, but if they struggle to exhale, it points to disease deeper inside the chest. When we're trying to figure out how well oxygen is actually getting into the blood, it's crucial to know that the little SpO2 monitor clipped to their tongue isn't giving us the whole story. The true gold standard for checking ventilation is a blood gas analyzer, which measures arterial oxygen partial pressure, or PaO2. The catch? Those machines are super expensive, and not every clinic has one on standby. That's exactly why vet professionals have to deeply, fundamentally understand how to interpret those standard SpO2 monitors. Now, what's really interesting about this next concept is how it bridges that gap. It's called the oxygen dissociation curve. It's this sigmoidal or S-shaped graph. The steep, plunging part of the curve represents the body's tissues practically begging for oxygen. Here, even a tiny drop in pressure causes the blood to dump a ton of oxygen. The flat plateau at the top, that represents the lungs, where the blood stubbornly holds on to oxygen, even if the pressure wobbles a bit. Understanding the shape of this curve is the master key to decoding those monitor readings. So, to put that into perspective, let's look at how these numbers play out in real life. A healthy partial pressure of 100 millimeters of mercury gives us a nice, safe SpO2 reading of 98%. But watch what happens as we slide down that S-curve. By the time partial pressure drops to 60, our SpO2 monitor reads 90%. If a patient falls below that 60 threshold, they are in severe hypoxemia. If they don't respond to supplemental oxygen right away, mechanical life support has to be considered instantly. The margin for error here is literally razor thin. And that brings us to our final takeaway for today. We've seen that a humble rat isn't just a robot running on instinct. It has a genuine, multidimensional empathy profile that compels it to free a friend in distress. We've also unpacked the incredible complexity of an animal's physiological needs and the rigorous, highly structured science it takes to monitor their vitals and keep them alive. So, if animals really do possess such nuanced emotional worlds and such fragile, complex physical bodies, how does the science of observation change what we owe them? How does it change our care, our research, and how we treat them every single day? It's a huge question and definitely one worth pondering long after this explainer ends. Thank you so much for joining me today, and keep observing.